Good morning, students. So in previous lecture, we have studied about the image formation by the concave and the convex mirror. So in convex mirror, so there are only two image formed by the mirror. So when we put object at the infinity, so when we put at object infinity, so image form where at the focus. So this image what is this nature of this image is what is virtual and erect, and this image what is that is diminished size, very small size. So size is small and nature is what is virtual and erect, and what is the position where at the focus. And next case, so we put object beyond the pole. So when we put object beyond the pole, so where image form between P and F. So what is P here? Pole, and F is focus. So this image form what is small size, and what is the nature of that? Virtual and erect. And in next slide, we study about what? Magnification of the mirror. So what is the magnification of a mirror? Minus V by U. So what is V here? V is image distance and U is object distance. And we can also write magnification in term of a image height and object height. So H dash by H, this is height of the image, and second this is height of the object. So this is formula in term of a heights, and this formula in term of a image and the object distance. And we can also write formula of a mirror formula, that mirror formula 1 by F, F is what is focal length, is equal to 1 by V plus 1 by U. So V here image distance and U here what is object distance. And here we consider the sign convention. So what are the sign of a different here parameters? So for example H, so we take H positive because when we put object above the principal line, so we take H positive. So always we put object at the principal axis, so that always positive. Second, sign of the image or a H dash may be negative and this positive. Image form below the principal axis. If image form below the principal axis, it becomes what is negative, and when it form above the principal axis, so it becomes positive. And next, what focal length and the radius. So focal length and radius are negative because all left hand distance taken as negative and right hand distance taken as positive. So this is the sign convention, and we also call that new sign convention or new Cartesian sign convention. And here relation between R and F, radius is equal to double of focal length. So this is a relation between radius and focal length, and F is equal to R by 2, that is half of the radius. So one part of that chapter were complete, that is reflection. So that is next part, what is refraction. So basically what is refraction? So refraction, when light going from one medium to another medium, then its path change. Okay, so this is what is refraction of a light. So in reflection, simply what is rebouncing of a light. When light strike with a polished material, that is polished mirror, so that rebounds light known as the what is reflection of a light. But here we take a transparent material. So when light going from one medium, for example, we consider here one medium is air and second medium may be glass or a water. So when one light enter from the one medium to other medium, so this path is changed. So we can understood with the example of that is taking a glass and air. So we understood with the help of a diagram. So we make here a glass slide. So that is particular thickness. So this is a glass slide, and we take here. So we write here, this is glass slide. And here what is air, and here this is what is glass. So this refractive index, that is known as the what is refractive index. So we write here N. So Na, refractive index of air, and this is Ng, refractive index of glass. Okay, and air medium is known as the rare medium. So this medium, what is rare medium? And this medium is denser medium. Denser medium. Okay, so what is rare medium? Which are lighter in weight or which have low optical density, that medium known as the rare medium. So we can write here what is this is low optical density. Low optical density materials, and this is high density materials. Okay. So this is a glass slide. We take here a ray of incident light which produced by the any source, maybe sun or a torch light. So basically this is a incident light So this strike point, this strike the first surface. So right here, this is XY interface, and this is X dash Y dash interface. Okay, so there are two interfaces. So light strike at the first interface. So we mark these by arrow. So this is what is incident light. So these produced by the torch. Incident light. So for example, light strike here. So we mark this point, what is M. Okay, so at this point we draw here normal. So this is basically normal, a perpendicular. So this is a normal. Okay, so here what are conditions when light going from air to glass? So air means here rare medium which have low optical density, and second medium which have high optical density, that is glass. So what is the rule here? When light going from rare to denser medium, it bend toward the normal. So where bend? Toward the normal. For example, this is actual path. So this is actual path of the light. So we mark here, this is actual path. And but light enter going from rare to denser medium, so it bend toward the normal. So it bend like this. And it strike here. Okay. So there are two types of a ray form. So one ray is original light and second is what is refracted light. So this light we mark here original ray of light, and this light what is refracted light. Okay, so here this angle is known as angle of incidence and this angle known as angle of refraction R. So I mark here this angle I, angle of incidence, and this angle R, this called what is angle of refraction. Okay, simply we mark here this is I1 and this is what is R1. Okay, so here this light strike here, this point. So we called this point what is N, and we mark here another perpendicular. So we mark here, so this is another perpendicular, and this is one perpendicular from here to here. Okay. So this light enter here. So when light going from denser to rare medium, so it bend away the normal. So this is actual path. This is actual path, but it bend away like this. Okay. So here see this make angle with this is what is I2 and this make angle this is what is R2. So sometime this R2 known as the angle of the emerging E. So we write here R2 is equal to E. So angle of the emerging. So here see when light entering in the slab and comes out from the slab. So here we see that original ray parallel to the refracted ray. So this is the refraction of a light through a glass slide. So here what we have learned, first of all, what is refraction? So refraction is a phenomena changing of light from one medium to another medium. So basically it's depend upon the type of the medium. So one medium is what is higher optical density and second medium what is low optical density, and that medium which have low optical density, that is known as what is rare medium, and which have high optical density, that is known as the denser medium. Okay, so here, so this phenomena is known as the refraction of a light. So here we can find out how much this refracted ray refracted from the original path. So how we can calculate, draw here normal. So how to draw normal here? So take perpendicular here on this line. So this angle is 90 degree and this point known as, for example, this is N and this is K. So NK is what is perpendicular. So nk perpendicular on the original ray. So we can measure this path. So this path may be measured how much, maybe 4 centimeter or 3 centimeter using scale. So we can find out how much ray is reflected from the original path. So you can measure by using this scale. For example, this is 4 centimeter. Okay. And this angle and this angle are equal. So angle I1 is equal to angle R2. So angle of the entering of a light is equal to angle of the emerging of the light. So that angles depend upon the thickness of the slabs. What is the thickness of the glass slab? So what are here rule of a refraction of a light? So first rule, what is? When light enter into rare to denser medium, light enter rare to denser, so bend toward the normal. What is bend toward normal? And when is reverse, when light going from denser to rare medium, it bend away the normal. What is bend away the normal? So this is basically what is refraction. And what are the laws of a reflection? So law of a reflection, and ratio of the angle of a sin I to the angle of the refraction are always constant. So what is law? So first, angle I, so we can write sin I by sin R is equal to constant. Okay, so this is first law. So we call that ratio of the angle of a incidence of a sin to the angle of a refraction of a sin to each constant. What is constant? Constant quantity here. What is the refractive index? So simply we write here sin I but a sin R is equal to constant. So we can write simply K or a constant, and that is equal to refractive index of denser medium. So what is refractive index of a denser medium here? What is Ng? And what is refractive index of this medium? That is Na. So we can write this is equal to Ng by Na. So basically what is refractive index? Refractive index is the characteristics of a medium. So, and we can write refractive index is ratio of the velocity of the light to the velocity of the medium. Okay. And second law, so this is first law. And second law here, here what? Incidence ray, refracted ray and normal. So here three things: incidence, incident ray, refracted ray and normal are lie in same plane. So it means they are not changing the plane. So they are lie only a single plane, like in a vertical plane. So light comes in vertical plane, and this is normal, and they goes after they moving in the different direction in same plane. So that is moving in same plane. So for example, they are moving only a vertical plane. So this is a refraction of a light. And next, we study about refraction of a light through a lenses. So there are the two types of a lens. One type of a lens is convex and concave. So this lecture we continue in next day. So here we complete this topic of a reflection and the refraction. So next we study about the image formation by the convex and concave. Thank you very much.